So this video is all about calculating compound interest, and it's a little bit different than simple interest, in that compound interest is snowballing interest and follows an exponential model. There is one main formula that we have for compound interest, and there it is right there. It looks like a mess, but it's not really that bad. It's very similar to the simple interest. My A is my future amount. My P is the principal that I'm starting with, a given amount of money. My R is my interest rate, my T is time, and the one thing that is different here is this variable called N, and N represents the number of compounds per year. Here are some typical compounds per year, and these numbers look sort of strange and sort of random, but it's based upon per year. So what we have is N equals to 12 would represent a bank giving you monthly compounding. N at 52 would be a bank that gives you weekly compounding. 365 is daily compounding. 1 is annual compounding. 2 is semi-annual compounding. And 4 is quarterly compounding. Depends what bank you're going to and what banks offer, but those are some of your typical numbers based upon the number of times your money is compounded per year. Now, let's take a look at some examples of using this formula in a similar way we did to simple interest. And here's what we have for the first one. And I'm going to mark up the numbers on this just like we did for simple interest. I see the word compounded. What I want to do is I want to find out how much will be in the account, the total amount A. I am starting with $3,000 for 5 years at 2% compounded quarterly. So again, the pink highlighter tells me what type of formula I am going to use and what type of problem I have. It's compounded, so I use that formula. I want to calculate how much money will be in the account. So here I go plugging in the numbers into my formula. I'm starting out with $3,000 for my principal. My interest rate is 2%, 0.02. This N, the number of compounds per year, is going to be 4 because this is quarterly. My N value is 4. I'm going to let the money sit in the bank for 5 years. So there are all of my values into my formula. From here, it becomes a calculator problem. 0.02 divided by 4 is 0.005. 4 times 5 is 20. Now, here's where we need to be careful with our calculators. 3,000 and 1.005 exponent that is raised to the 20th power is 1.1049. The future amount that I have in my account when I multiply those two values together is $3,314.70. I earned a free $314.70 starting with $3,000 using those different variables that the bank gave me for my account. Key is plugging in the right numbers and using your exponent key. So let's ramp this up a little bit. Let's say Donald Trump has put $10,000 in a CD. Let me mark up what type of problem this is. This is a compound interest problem. So I am going to use this formula, not any of the simple interest formulas. What will be in the bank, the amount in the account for Donald Trump's grandchild, if The account began with $10,000 in it. It earned 4% interest. It was compounded monthly, and the grandchild gets the birthday gift, the birthday check, when the grandchild turns 25 years old. So let's plug in the numbers. $100,000 was deposited in an account. The interest rate, change that to a decimal. This time my end value is going to be 12 for monthly compounds, and the T value, the money is going to sit in the bank for 25 years. So the future amount is $100,000. I have all of the numbers in my formula correct. I am going to say 0.04 divided by 12, get 0.00333. 12 times 25 is the 300th power. The future amount is $100,000. 1.00333 raised to the 300th power is 2.71106. When I multiply these values together, that grandchild would receive $271,106 on the 25th birthday, based on an initial deposit of $100,000 under these conditions. That's a pretty good deal for that grandchild. Let's ramp this down a little bit and do the same problem, except this time for number 3. Let's say when you were born, your grandparents deposited $10,000 in an account for your college education. I see the word compounded. I want to figure out how much will be in the account for your college education under these conditions. So there's $10,000, 5%, and it's compounded annually. So I'm going to go back to this formula. Let's start plugging in the values. Your grandparents deposited $10,000 for you. The interest rate that they had in this account for you was 5%. It earned compound interest once a year, so annually. My N is 1. And most people start college around their 18th birthday. So let's say you started when you were 18 years of age. That is my time that the money sat in the bank for you. So I have 10,000 times 1.05. 1 times 18 is 18. So my future amount is 10,000. 1.05 raised to the 18th power is going to be 2.4066. The amount that you have in the bank for your college education is $24,066. That's how much you would have under these conditions, starting out with 10,000, 5% interest compounded annually for 18 years. Let's get even more futuristic. Let's say you deposit $5,000 for your child's college education, where it gets a little futuristic. You know that your money is going to be compounded. How much money will be in the account? You start out with $5,000 at 2% compounded semi-annually. So I have all of these values highlighted. I know what formula I'm going to use because of the word compounded. Let's start plugging these values in. The future amount, you've deposited $5,000. You receive 2% interest rate. Compounded semi-annually, my N is going to be 2, and here's where it gets more futuristic. When will your first child start college? Well, they haven't been born yet. They have to turn 18 years of age. Let's say you have your first child in 12 years. Add another 18 years onto that. In 30 years, your child will be a freshman in college. So 30 years is how long that money will sit in the bank. 5,000, 1.02 divided by 2 is 0.1 raised to the 60th power. So 5,000, 1.01, my exponent key, 1.8167, the amount that you will have for your future child for their college education is $9,083.50. Under those conditions, that's how much money would be there for them.